today we are doing or continuing linear programming. And the other day we did 5 steps. Now tomorrow we're going to add the rest of the steps, which takes us to a total of 12. So let's just refresh on the first 5 that we talked about the other day. Step number 1, remember that you have to graph your constraints. Step number 2, you had to shade the feasible region. Step number 3, you needed to calculate your vertices. Step number 4, plug vertices into the profit equation. Step number 5, determine the point that satisfies the max or min, depending on which one is required by the problem, right? So these are the 5 steps. We did one example the other day. I'd like to do another example. Talk about where that goes. So here we go with example number 2 is where we left off, right? All right, here are the constraints we're going to start with. I want to go with 2 is less than or equal to x, less than or equal to 6. I want to go with 1 is less than or equal to y, less than or equal to 8. No, let's go 5. My bad, make that 5. 1 to 5. And then let's do x plus y is less than or equal to 8. The profit equation, so P equals is 3x plus 2y, and this time we're looking for a maximum.
Didn't you say like the first 2 didn't matter, right?
That's not what I said. What I said the other day was when we have x is greater than or equal to 0 and y is greater than or equal to 0, that meant first quadrant. That's all that meant. That's not the case here. Okay, so first thing we have to do is graph our constraints. So this says that x falls between 2 and 6. What kind of lines are x equal lines? Up and down, vertical, right? So I'm going to have a vertical line at 2 and a vertical line at 6. Where's 2? Here's a vertical line. And then 3, 4, 5, 6. Here's a vertical line. And right now I am shading in between those. Oh, wait. Now I have y is less than or equal, or sorry, 1 is less than or equal to y, less than or equal to 5. Those are horizontal lines. That's going to go this direction at 5 and at 1. And it is shaded in between there. So right now, we technically are shading inside this beautiful box right here, right? Okay, we have one more to graph. That is my x plus y is less than or equal to 8. I'm going to do it by intercepts like we did the other day. Here's my x and my y. If I put 0 in for y, I get what for x? 8. If I put 0 in for x, I get 8 for y. So I'm going to come out here. Here's 6, 7, 8. I'm going to put a dot here. And 5, 6, 7, 8. I'm going to put a dot here, and I'm going to connect my dots. And it is less than that. So our feasible region is this section right here. So we've graphed our constraints. Now we are shading the feasible region. Next, we have to find the vertices. This vertex right here is at a cross point. What was that one? 2, 1. Very good. This one is also at a cross point. What is that one? 6, 1. Should be 1, 2, 3, 4, 5, 6. Yeah. 6, 1. Okay. This one is at a cross point. What's that one?
2, 5.
Good. 2, 5. Now, these two, however, we have to calculate. We are doing between, let's start with this one. This is the diagonal line, x plus y equals 8, and the vertical line where x equals 6. So I know my x value has to be 6. If I plug that in here, what does my y value have to be? Good. All right, so that's that point. This one also falls on that x plus y equals 8 line, but this time I know y is 5. Yeah, so this point is 3, 5. Because it falls right on this vertical line right here, which was x equals 6. Okay? That's why. And this one fell right on this horizontal line where y equals 5. That's why I did that.
Wait, so I'm not allowed to just look at my graph and be like, that's
Nope. Nope. Okay, so now the next step is to take all 5 of those and plug it into our profit equation. You have to calculate all of them. Right, it's because they were right on like a vertical and horizontal line. So anything that falls on this line, x is 2, right? Anything that falls on this line, y is 1. So I knew that this point had to be 2, 1 because it's a vertical horizontal line cross. Okay. All right, so we're going to plug it into our profit equation. I'm going to start with this one. So I have 3 times 2 plus 2 times 5. 3 times 2 is 6 plus 2 times 5 is 10, so this is 16. Right? I just did 2, 5. Which way you want to go? You want to go this way or you want to go backward? Clockwise this way? Okay. So we have 3 times 3 plus 2 times 5. 3 times 3 is 9 plus 2 times 5 is 10, so this is 19. Then we go to this one. 3 times 6 plus 2 times 2. This is 18 plus 4, or 22. Then I got to go to this corner. 3 times 6 plus 2 times 1. What does that one equal?
20, right?
18 plus 2 is 20, I agree. And then we have this last one right here. So 3 times 2 plus 2 times 1. What is that one? 8. All right. So now we were looking for the maximum. Which one of these points gives us the maximum? 6, 2 right here. I'm going to circle it in my work. And I'm going to put underneath maximum at 6, 2. Can we try another one? Ready for another one? Example number 2 or example number 3? Let's do trying to decide which one I want to do. All right, let's do this one. Example 3. Here are our constraints. Let's go with 4x plus 2y is less than or equal to 16. Let's go with 3x plus 3y is less than or equal to 15. Let's go with x is greater than or equal to 0, and y is greater than or equal to 0. And our profit equation is 3x plus 2y, and this is a maximum. Oops. All right, so first thing we do is have to graph the constraints. X and y make it the first quadrant. Graphing this one, I'm going to do it by my intercepts. If I put 0 in for y, x equals what? 4. If I put 0 in for x, y equals what? 8. Let's plot those 2 points. 4, 0, right here, and 0, 8. I'm going to connect my dots. All right, next one. Again, I'm going to plot it by intercepts. 0 in for my y, x equals. If I put 0 in for my y, or for my x, y equals 5. So I'm going to go 4, 5 right here, and 1, 2, 3, 4, 5 over here. Connect my dots. Now, where am I shading? Both of these are less than, so what part am I shading? Below both of the diagonals. So my feasible region is this beautiful four-sided figure right here. What is the next step?
Like plot your points or like figure out what they are.
Find your vertices, right? Okay, well we know obviously this corner is at 0, 0. Maybe, there we go. We know this one is at where?
0, 5.
Good. 0, 5. We know this one is at where? 4, 0. And so we just got to find this one. And the two lines that make that are these top two equations. Now, right now, they don't have the same but opposite on either. What can I multiply the top one by? Can I do -3? And the bottom one by? 4. Okay. So we'll get rid of our x's. Let's do that. So -3 times 4x is -12x. -3 times 2y is -6y. We're going to make those equal signs while we're doing our calculation. And -3 times 16 is -48. Okay. Next one. 4 times 3x is 12x. 4 times 3y is 12y. And 4 times 15 is 60. To add these together, our x's drop out. We get 6y equals 12. So y equals 2. All right, so far I know the y value is 2. How do I find the x value?
Plug it back into the
Yep. So I'm going to take and plug 2 right back in here. So I have 4x plus 4 equals 16. Subtract 4 over, I get 4x equals 12. Divide both of them by 4, and x equals 3. All right, so now I have 4 points I have to plug into this equation to find out which one's the maximum. Okay? All right. So I have 3 times, and again I'm going to start here, 0 plus 2 times 5. That gives us 10. Let's go to the next one. I have 3 times 3 plus 2 times 2. So that's 13. Okay, check my math. It's been a long weekend for me too. Let's go. 3 times 4 plus 2 times 0. 12. And my last one, 3 times 0 plus 2 times 0 is obviously 0. Which one gives us the maximum? 3, 2. I'm going to circle it. And as the last step, I'm going to say there is a max at 3, 2. All right, I want to do one last one, you guys, because all I've done are maximums so far. I want to show you what a minimum looks like. Okay, you need to see what that's like, and then you guys can start on your 3 problems. So one last example, okay? Example number 4. Let's go with, make sure I'm choosing a good one here. Yeah. Let's go with 2x plus y is greater than or equal to 300. Let's go with x plus y is greater than or equal to 200. And let's do x is greater than or equal to 0, and y is greater than or equal to 0. And let's say that we want a minimum for the profit equation. P equals x plus 3y. So the very first thing we have to do is graph the constraints, right? Now these last 2 again mean that it's in the first quadrant. So that's what I'm going to do is just draw my first quadrant here. Okay, again, I'm going to do this. I put 0 in for y, x equals what? If I put 0 in for y, x equals what? 150, thank you. 150. If I put 0 in for x, y equals 300. All right, so I'm going to go, there's 50, 100, 150, 200, 250, 300. So I have 150, 0, so right here. Nope, wait, sorry, right here. My bad. I went by 50s. And on this side, let's go 51, 152, 253. So here's this one. I'm going to connect my dots. Next, I'm going to do it by intercepts again. So if I put 0 in for y, I get 200. If I put 0 in for x, I get 200. So here's 200. Here's 200. I'm going to connect those. Now this time, you guys, you'll notice that these said they were greater than, which means I'm shading above. So in this case, it's actually everything out here is where I'm shading, because it's greater than. And this, of course, would go on forever. So now this has only 3 vertices. Here's 1, here's 2, and here's 3. Right? 3 vertices that connect it. So here's the first one. It's actually on the x-axis, so we know this is at 200 and 0. What's this one up here? 0 what? 300. Very good. All right, now we got to calculate that one. Madison, what do you think it looks like? Well, if you want to just look at the graph and guess what that point is, what do you think it looks like?
Is that
100, you think?
I don't even know what you went up on the side.
I went by 50s.
50.
You're going to guess 100, 100? Well, let's do our calculation and see how close you are.
Probably not very close.
So, what can I multiply up here if I want, let's say, the y's to drop out? Let's get rid of the y. So I'm going to say -1 on the bottom one, okay? So the top one I'm going to leave alone and say I have 2x plus y equals 300. I'm going to multiply the bottom one by a negative, so I have negative x minus y equals negative 200. If I add these together, I get x. My y's drop out. 300 minus 200 is 100. Oh, you're doing good so far. Let's plug our x back in. So it goes here, right? So I have 2 times 100 plus y equals 300. 200 plus y equals 300. So y equals 100. So this point is 100, 100. Okay, so it worked where you could see it, but it doesn't always, because it depends on your drawing, right? Yeah. Okay, so now what do I have to do with those 3 points? Yes, plug them in to find our minimum. So we have P equals my x value plus 3 times my y value. So in this case, we get 900. Next one is my x value plus 3 times my y value. That's 100 plus 300, or 400. And the last one is my x value plus 3 times my y value. So I get 200. That is a 3. So this is the minimum. I'm going to circle that. So I'm going to say I have a min at the point 200, 0. So you guys, give me questions. No questions? We're okay? All right, you have 3 problems to do, 10, 11, and 12. 10 and 12 are maximums, 11 is a minimum. You guys got this. Totally got this.